Good morning everyone. Today we are going to explore the fascinating and potentially destructive power of static electricity, and the charge dynamics of rubbing materials together. We will be investigating the static charge created when a ebonite rod is rubbed with fur. This process results in a negative charge. Get ready to learn something new and exciting. Natural destructive phenomena such as lightning and earthquakes can cause severe damage to lives and property. Lightning is a streak of bright light and sound caused by electric discharge between clouds and earth or between different clouds. Earthquakes occur when there is a disturbance deep inside the Earth's crust and have the power to wreak havoc, posing a significant threat to our safety and well-being. Friction is a powerful force of nature that can be used to generate static charges. This is done by rubbing two objects together. The atoms of the objects interact with each other, causing them to draw in light objects like pieces of paper. This is known as charging by friction. An example of this is if you rub a plastic refill, scale or comb with dry hair, paper or plastic, it'll acquire a charge and be able to pick up pieces of paper. These charges are known as static charges as they are not in motion but remain in the same place. On the other hand, when charges move, it is known as electric current. This is the motion of charges through a conductor. An example of like charges repelling each other can be seen using two balloons. Hang them in such a way that they do not touch each other. Rub the balloons with a piece of woolen cloth and then let them go. You will see they repel each other. The same can be done with two plastic refills, which are rubbed with polythene and then brought close together so that they produce the same repulsive effect. This experiment aims to investigate the power of attraction between two objects with unlike charges. To commence, a plastic refill is charged by rubbing it with polythene and placed inside a glass tumbler. Then, an inflated balloon is charged by rubbing it with a piece of woolen cloth. As the balloon is brought near the plastic refill in the glass tumbler, the attraction between the two objects with unlike charges will be demonstrated. This experiment serves as an example of how objects with unlike charges can be attracted to each other. Static charges are powerful yet invisible forces that can have a notable influence on the objects around us. To demonstrate this, we have two rods, one made of glass and one made of plastic. When the glass rod is rubbed with silk, it takes on a positive charge, and when the plastic rod is rubbed with fur, it will become negatively charged. This classic science experiment is used to demonstrate the concept of electric charges. Through exploration, experimentation, and observation, we can gain an improved understanding of the forces that control our world. When two materials are rubbed together, the one in the higher order gets a positive charge and the one in the lower order gets a negative charge. This is known as static electricity. As an example, when a glass rod is rubbed with silk, it becomes positively charged, and when an ebonite rod is rubbed with fur, it creates a negative charge. This demonstrates how opposite charges of materials can impact each other. Exploring the principle of an electroscope, a device used to detect the presence of an electric charge, is the focus of this slide. It works on the basis of the repelling force of like charges. All that is needed to create a simple electroscope is an empty bottle, a piece of cardboard, a paperclip and two small strips of aluminium foil. The paperclip is passed through the cardboard and the aluminium strips are hung from the other end. When a charged body is brought near the paperclip, the aluminium strips repel each other, indicating that the body carries an electric charge. If the body is uncharged, the aluminium strips remain unaffected. Electroscopes are used in laboratories and research facilities to detect and measure electric charges. Electric charge is an impressive phenomenon that can be observed in various ways. Charging by contact or conduction is the exchange of charge between two bodies when they come into contact. This can be seen when a charged plastic rod is brought near an electroscope, which causes the metal strips on the electroscope to repel each other. Additionally, when two objects of opposite charges are brought together, the charge is transferred between them and they begin to interact due to the attraction or repulsion of like and unlike charges. This transfer of charge is an impressive illustration of the power of electric charge. Static electricity has the power to produce negative charge. This can be observed by rubbing an ebonite rod with fur, which produces friction between the two materials, resulting in electrons being transferred from the fur to the ebonite rod. This then builds up a negative charge on the rod. A positively charged object placed near the rod will cause the negative charge to spread out, which can be seen in an electroscope, a device that measures the amount of positive or negative charge present in a material. This demonstrates how two objects with opposite charges can react to each other. Electric discharge is the transfer of electric charges from one body to another, or from a charged body to the earth. An example of this is when a charged electroscope is touched and the metal strips collapse, known as earthing. Earthing is provided in buildings as a way to protect against electric shock. Though this process of electric charge discharge is generally beneficial, it can be destructive in some cases. Therefore, it is important to ensure proper earthing in residential and commercial properties. Lightning is a result of the separation of charges in the clouds, where positive and negative charges are separated between the upper and lower parts of the clouds, and the ground. When enough charge gathers, an electrical discharge travels from the clouds to the earth, creating lightning and thunder. Benjamin Franklin was the first to recognize the electric nature of lightning, and lightning protection systems can help minimize the risk of damage it causes. Lightning is a powerful and destructive force that can cause extensive damage to buildings and their inhabitants. To safeguard our properties, we should consider investing in a lightning conductor. It typically consists of a metallic rod, which is pointed at the top and embedded with a metal plate in the ground. This device helps redirect the lightning strike from a building to the earth, thus protecting it and its inhabitants from potential damage. With a lightning conductor, we can guarantee the safety of our homes and businesses. When it comes to protecting yourself from a lightning or thunderstorm, safety measures must be taken. Open vehicles, open fields, and elevated places are not safe. Carrying an umbrella, while helpful in other situations, is not effective in this case. If you are in a forest, look for a low-hanging tree and take shelter underneath it. If you are in an open field, stay away from taller trees and metallic objects, and instead squat on the ground with your hands on your knees and your head between them. Indoor safety precautions should be taken as well. Stay away from electrical outlets, telephone cords, and metal pipes, if possible. Use mobile and cordless phones instead of wired phones and unplug electrical appliances such as TVs and computers. Refrain from taking baths or showers during a thunderstorm and avoid coming in contact with running water. Earthquakes are powerful and destructive natural occurrences that can cause substantial damage to life and property. They are caused by a disturbance in the Earth's crust, resulting in the ground shaking abruptly. This shaking can damage structures such as buildings, dams, bridges, and more. Earthquakes can likewise spark landslides, floods, and tsunamis, the last of which are usually caused by seismic activity. Tsunamis are huge waves that can reach colossal heights, destroying coastal communities. Being prepared for an earthquake is essential, as is taking safety measures prior to the occurrence of an earthquake to mitigate its impacts. Earthquakes are caused by the interaction of tectonic plates, the colossal slabs of lithosphere that make up the Earth's crust. These plates come together at fault lines, also known as seismic zones, which can build energy from friction until they slip, resulting in seismic waves that can bring about immense damage, including rupture, shaking, and landslides. Earthquakes usually happen in seismic zones, places of extremely intense plate activity, and can have an effect on areas far away from the epicenter. Earthquakes are a natural phenomenon that can cause strong seismic activity. India is seen as one of the most seismically active areas on the planet. The seismic zones in India are composed of the Kashmir region, the Himalayas, the Indo-Gangetic Plain, the northeastern region, Kutch, Rajasthan, the Andaman and Nicobar Islands, and some parts of South India. The magnitude of an earthquake is ascertained using the Richter scale, and earthquakes registering 7.5 or more on it can be extremely damaging. Earthquakes create seismic waves that can be detected by a seismograph. Understanding the tectonic activity within these zones is imperative for the security and welfare of citizens. The Indian subcontinent is familiar with the destructive power of earthquakes, as much of the region is classified in a seismic zone with earthquakes registering up to 6 or higher on the Richter scale. These seismic zones have been mapped, and seismographs are essential tools for detecting and measuring the intensity of earthquakes. With data gathered by seismographs, we can better comprehend the seismic zones of India and how to adequately prepare for and reduce the potential destruction caused by earthquakes. In an earthquake, it is necessary to ensure buildings are reinforced to resist shaking and heavy items are not attached to walls. When an earthquake occurs, safety measures should be taken. If indoors, take cover under a table, and if in bed, remain there. When outside, find a space away from buildings, trees, and power lines and lay down. If in a car or bus, ask the driver to reduce the speed and stay inside until the tremor ends. Knowing these safety tips can help protect from earthquakes and their force. Earthquake damage can be catastrophic. An earthquake is a violent shaking of the ground caused by the sudden movement of two sections of the Earth's crust, resulting in the release of energy in the form of seismic waves. These seismic waves can cause destruction as they travel through the area. Earthquakes can also trigger landslides, tsunamis, and other seismic activity, which can create huge risks to life and property. To help reduce the risks posed by earthquakes, it is essential to be prepared and to take appropriate safety measures. An earthquake is a sudden shaking of the ground due to the abrupt movement of the Earth's tectonic plates. The destruction inflicted by it can be immense, with its potential to affect areas far away from the epicenter. Ebonite rods, when rubbed with fur, can accumulate negative charge, making them more prone to lightning strikes and possible power surges in case of an earthquake. To safeguard your family and home from the potential repercussions of static electricity, it is important to understand the risks and take the necessary steps. Tsunamis are one of the most devastating natural disasters on Earth, resulting in billions of dollars in destruction and the loss of thousands of lives every year. Unfortunately, it is difficult to predict tsunamis as often localized wave surges are mistaken for them. Knowing the signs to look for can help to prepare and protect yourself and your family in case of a true tsunami. Tsunamis are formed by a variety of natural disasters, including earthquakes, volcanic eruptions, landslides, and meteorite impacts. Earthquakes can cause powerful waves on the ocean's surface due to the sudden displacement of the ocean floor. Volcanic eruptions can also cause tsunamis when the shock wave hits the ocean. Landslides into bodies of water can generate large waves, and meteorite impacts can also trigger tsunamis when a large body of water is disturbed. All of these can lead to significant destruction on land and in the ocean.